This is a video about more redox reactions. Look at this redox reaction and let's recap. We have aluminium plus iron oxide gives you iron plus aluminium oxide. The aluminium is oxidized to give aluminium oxide. The iron oxide is reduced to give iron. To investigate this further, I want to write some half equations. Half equations explain what happens to only one of the reactants. Let me show you. Aluminium starts as aluminium metal, so aluminium atoms. Then it becomes aluminium oxide, where we have the aluminium ions, the positive metal ions, attracted to the oxide, the oxygen ions, the negatives. So it changes from an atom, uncharged, to an ion, charged. We're going to write that down. So we have aluminium, and that becomes aluminium ion. Now it's in group 3, so it ends up with 3 plus charge. But we have to balance these things. So if it has a positive 3 charge, then it must have lost 3 electrons. So we write them separately. That is a half equation. Now let's look at the half equation for iron. Iron starts as iron ions in the iron oxide. Be very careful about how you say that. Then it changes to iron atoms in the metal iron here. So we have iron 3, which means that it will have a charge of plus 3, and that will change into the iron in the metal, iron atoms that are neutral charges. In which case, to do that, it will need 3 extra electrons. And there we have the half equation for what happens to iron. Well, what happens to the oxygen, our third element that's involved? Well, it's oxide here, so oxygen ions, and it's oxide here, oxygen ions. So, as it happens in this case, the oxygen ions remain unchanged. So these are the half equations showing the change from atom to ion or ion to atom, and what happens to the electrons that are involved as well. But so what? Why is this important? Well, let's go back to this equation again. The aluminium is oxidized to aluminium oxide, and in the process it changes from an atom to an ion. It becomes positively charged. In fact, it loses electrons. The iron changes from iron oxide to iron here. It gains electrons and becomes neutral. And we can define reduction and oxidation in terms of what happens with electrons as well as what happens with oxygen. That allows us to talk about redox reactions, not just about oxides gaining and losing oxygen, but in terms of losing or gaining any non-metal. So in this case, aluminium is oxidized. So oxidation is the loss of electrons when electrons are separated. And reduction is the gain of electrons. We remember this as oil rig. Oxidation is loss, reduction is gain of electrons. Let's look at this example and write some half equations. Let's start with magnesium. So we have the magnesium atom here as part of the metal, and that becomes magnesium ion. Well, magnesium's in group 2, so it will lose 2 electrons and become magnesium 2+. And that will mean that there are 2 electrons as it's lost those 2 electrons. Then let's look at the zinc. The zinc here is with zinc chloride. It's ionically bonded to the chloride. So it's going to be charged. Now I have to learn these charges. And zinc happens to have a positive 2 charge. So zinc will then need to gain 2 electrons and become zinc atoms in the zinc metal. So here, the magnesium, it loses those 2 electrons, they become separated. Oxidation is lost. Magnesium is oxidized, whereas the zinc gains those 2 electrons, becomes the zinc metal. So it is reduced. So this is oxidation, this is reduction. And what happens to the chlorine? Well, the chloride ions remain as Cl-, they are unchanged. So hopefully at the end of this video you can see that we can write half equations to show the change from atoms to ions or ions to atoms. And if we use that, we can work out which has been lost electrons, that would be oxidation, and which has gained electrons, that would be reduction.